All right, today we are chapter 6, lesson 7a, which is about solving inequalities again, but this time we're using positive numbers and we're going to be multiplying or dividing. So that's your learning target, is I know how to solve positive inequalities by using the multiplication and division properties of inequality. So, first things first, let's talk about how to solve inequalities. For these inequalities, we have to use the multiplication and division properties of inequality, which say that if you multiply or divide by the same number from each side of an inequality, the inequality will remain true. Therefore, if a, b, and c are all real numbers, then if a is greater than b, then a times c is greater than b times c, and a divided by c is greater than b divided by c. Okay, same thing goes with if a is less than b, then a times c is less than b times c, and a divided by c is less than b times c. So essentially what that's saying is that if you multiply or divide the same number on both sides of an inequality, just like an equation sign, everything is going to stay balanced and things won't really change. Okay, let's do a couple of examples of this so you can kind of see it in action. All right, example 1 says that we need to solve 5 times x is greater than 30, check our solution, and then graph that on a number line. So pretty much what we're asking here is what values of x would make it so that 5 times that number is going to be greater than 30. And that's what we want to know. So the first thing we need to do, just like we would in a normal equation, is divide by 5. Because 5 is being multiplied by x, we want to get x by itself. We have to do the opposite of multiplication, which is dividing. So 5 divided by 5 is just 1x. And if we divide by 5 on the other side to keep everything balanced, 30 divided by 5 is going to be 6. And we have x is greater than 6. That means x has to be greater than 6, essentially is what that means. So if we want to check our work, we're going to choose a number to make sure that this is correct. Let's choose 7 for x. So we're going to check. We're going to plug 7 in for x. So we have 5 times 7. We want to see if that's greater than 30. 5 times 7 is 35. And that is greater than 30, so that checks out. It works. That means 5 times 7, yep, that's greater. Okay, so we've checked our work. Now we just have to graph it. We're going to make it a little number line here. And remember, we want our middle number to be our key number here, which is 6. And we'll go up to 7, 8, 9. And we'll go back to 5, 4, and 3. Just to keep everything balanced here. All right, so it says x is greater than 6, not equal to. That means we have an open circle here, and we need to find the values that are going to make this true, which means that it is anything above 6. So we're going to shade in the higher side up here. That's because 7 will work, 8 will work, 9 will work, 6.1 will work to make this inequality true. However, 5.9, 5, 4, 3, on down to the negatives, that'll make that an untrue statement. Okay. All right, last example here. This is example 2. We want to solve h divided by 4 is less than or equal to 3. Check our solution, then graph it on a number line. So we're first going to solve h divided by 4 is less than or equal to 3. And if we want to get rid of this 4 in the denominator, we have to multiply by 4 on both sides. Those will cancel out. We'll be left with just h, which is less than or equal to 3 times 4, which is 12. H is less than or equal to 12. So let's choose a number here, an easy number that we can check. What numbers that h could be is less than 12? Like, well, 10's an easy number. Let's try that. So we'll plug in 10 for h. So we're going to check. We're going to go 10 in for h divided by 4. Is that less than or equal to 3? So what we know here is we can actually, this is just a fraction, we could actually reduce this to make this a little bit easier to look at. And that would be 5 over 2 if we divide by 2 on the numerator and the denominator. We want to see, is that less than or equal to 3? And we know that 2 goes into 5 2 times. and we're left with 1/2, which is definitely less than 3, so that checks out. That is true. And sorry, I need to move this up a little bit. 2.5 is less than 3, and so that does work out. So now we need to graph this on a number line. And our key point, remember that's the one that we want to make sure that we have in here, is 12. And we'll go 13, 14, and 15. Go back down to 11, 10, and that's good. So 12 is our important number here. And because this is an equal to 2, we have to fill in this gap here, or the circle, because we want to include the number 12. We're not trying to not include the number 12, and we want to shade now. Well, 13, no, 13 is greater than 12, so that doesn't work. And 11 is less than 12. That means we want to shade in this direction, to the left. To the left, to the left, to the left, to the left, not to the right. All right, sweet. So that works out. We've now graphed our solutions on our number line, and that's all we have to do. Hope you enjoyed. Thanks.